You've seen it everywhere, right? ChatGPT writing emails, DALL-E making incredible art. Generative AI feels like it just exploded out of nowhere. But what if I told you that this entire revolution, this whole technological boom, can be traced back to a single moment, to one single revolutionary idea published in a research paper? Well, today we are pulling back the curtain on that exact origin point. So, what is the secret engine that's driving this whole AI revolution? That's the big question we're going to answer. We're going to uncover the one core breakthrough that took artificial intelligence from this slow, steady crawl to an absolute full-on sprint. Okay, to really get this, we've got to rewind the clock. Let's go back to the world of AI before 2017, because back then, AI development was kind of hitting a wall. There was this fundamental speed limit that was holding everything back. See, the big models at the time, things like recurrent neural networks, or RNNs, and their smarter cousins, LSTMs, they all worked sequentially. I want you to imagine trying to read a book by looking through a tiny little tube, where you can only see one single word at a time. That's literally how these models saw language. They'd read word 1, think about it, move to word 2, think about that, and so on and so on. And this slide just lays out the problem perfectly. The old way had two massive issues. First, by the time the model got to the end of a long paragraph, it would often, forget what was said at the beginning. The context was just gone. And second, because it was this one word at a time process, you couldn't just throw more computers at it to speed it up. It was fundamentally, structurally slow. But this new way we're about to talk about, well, it solves both of those problems in one incredibly elegant move. And then 2017 happened. A team of researchers at Google dropped a paper that would change absolutely everything. It introduced a totally new kind of architecture that broke AI free from that one-word-at-a-time prison. And they gave it this brilliant, absolutely iconic title, Attention is All You Need. It was such a clever nod to the Beatles song, All You Need Is Love. And you know what? It perfectly captured the paper's central disruptive idea. And the impact? It was seismic. Just look at this number. As of 2025, this paper has been cited over 173,000 times. To put that in perspective, that makes it one of the most influential academic papers of the entire 21st century, in any field. This wasn't just an update, it was a total paradigm shift. And this was the team that did it. The paper was the work of 8 researchers at Google. All of them are credited as equal contributors, which is pretty cool. But here's the fascinating twist in this story. Every single one of them has since left Google to start their own companies, and many of those are now huge players in the AI space. Talk about a legendary group. So, what was the magic inside this paper? How did the transformer, as they called their new model, actually work? Let's break down the 3 core ideas. And don't worry, we're not going to get bogged down in any complex math. Okay, first up is self-attention. This is the big one. This is the real game changer. Instead of reading word by word, the transformer looks at the entire sentence at the exact same time. It weighs the importance of every word relative to all the others. So, for example, in a sentence like, the robot picked up the ball because it was heavy, self-attention lets the model instantly figure out that the word it is way more connected to ball than it is to robot. It just gets the context in a flash. Next, the paper builds on that idea with something called multi-head attention. Now, if self-attention is like one super smart expert reading the sentence, multi-head attention is like having a whole panel of experts all reading it at the same time. Each head or expert is focusing on something different. Maybe one looks at grammar, another looks at the relationships between people and places, a third is checking the overall sentiment. By combining all these different viewpoints, the model gets a much, much richer and deeper understanding of the text. But hold on, you might be thinking, if the model sees all the words at once, how does it know what the original order was? I mean, the meaning of a sentence can totally change if you shuffle the words around. Well, that's where positional encoding comes in. It's this really clever trick that basically stamps each word with a mathematical serial number, telling the model exactly where that word was in the original sequence. It preserves the order, even while processing everything in parallel. Super smart. So, you have these 3 key parts: self-attention, multi-head attention, and positional encoding. You put them all together and you get a system that's both incredibly context-aware and this is the crucial part, massively parallelizable. This combination solved the speed problem and the context problem all at once. And with those barriers gone, well, the floodgates opened. This is how that one single paper launched a revolution. I mean, this timeline shows the turning point perfectly. For decades, progress in AI was steady, but it was linear. Then 2017 hits, the Transformer paper is published, and boom. Just 1 year later, you get Google's BERT and the very first GPT model from OpenAI. The pace of innovation just completely explodes. And from that point on, it's just this incredible cascade of innovation. You know, the T and BERT and in GPT, it literally stands for transformer. But it wasn't just language. AI models for creating images, like DALL-E and Stable Diffusion, video models like Sora, even models for image recognition, they all have the transformer architecture as their fundamental backbone. It became the universal blueprint for modern AI. So, the crucial takeaway here is this. One paper, with one core architectural idea, provided the foundational design that unlocked this entire generative AI boom we're living through. It solved the crippling limitations of the past and created a flexible, scalable blueprint that everyone started building on. We've seen how this one idea, the transformer, became the engine for the AI of today. It really makes you wonder, doesn't it? What seemingly simple, elegant idea is being written up in a research paper right now that's going to become the engine for the AI of tomorrow?